Yes, my name is Andreas Hallberg. I'm from a Swedish company called TrueSec. If you were at the previous session, you know a little about TrueSec. My colleague Emil Kvarnhammar talked about it. We are located in Malmö and in Stockholm in Sweden. I'm going to be talking about secure coding patterns. And please remember to engage through the GOTO application. And without further ado, let's get started. So I work at the company TrueSec. Here's us in South Africa on our company trip this year, actually. I spend my time at TrueSec developing and auditing security critical systems. Security is important, right? You need to discuss it not only with your kids, but with your colleagues as well. And the thing with security is that it's hard to tack on security on a project when it's nearly finished. It really needs to be an integral part of development for it to be successful. And today I'm going to be talking about some concepts and patterns that will help you in your daily coding activities. Specifically, I'll talk a bit about trust to set the stage in the beginning. I'm going to move on to the first pattern that's called domain-driven security. Then there's something called the untrusted pattern. I'm going to be talking about immutability, and I'm also going to be talking about something called the inverse life coach pattern. So let's get started. Trust, the foundation of software security. Well, it really is, because a lot of security issues boil down to a poor understanding of where we or our software is placing its trust. How do we control who we trust? How do we establish trust? These are really important questions if you want to make your software secure. So let's take a look at a typical interaction that can happen here. Here's a businessman, Bob. He's at the bank. He wants to transfer X euros from account Y to account Z. Okay. You know, what could possibly go wrong? This is a simple, typical transaction that you have in different forms in your applications, whatever that might be, of whatever kind your application might be. So let's look at the first interaction, the authentication step, as it's called. How can the bank be sure that Bob really is Bob? And how can the bank be sure, how can Bob be sure that the bank is indeed the bank, that they're talking to the correct party? And if we look at the actual operation that's to be performed, do we know that Bob owns account Y? Do we know that account Y holds X euros? And do we even know that X is a number? These are all things that our application has to handle. Otherwise, we're in trouble. Because, you know, Bob could really screw us here, or the bank could screw Bob, you know, depending on which side you're on in this case. So in order to visualize trust, it's pretty useful to think of your application as a circle, and there's a circle of trust, and your application is inside of it. So you have all this stuff, right, that's outside of your circle of trust, that's not trusted. You can't trust the user, the request data, the database, who knows what's in there? Is your application responsible for putting everything in there? Maybe not. Third-party services, etc., etc. So what you need to understand, what your application must understand, is where the trust boundaries are in your code. Where does trust begin? Where does trust end? And I'm going to apologize in advance for this next slide. You might want to cover your eyes. I just want to really hammer home this point about what's trusted and untrusted. Everything inside the circle is trusted, everything outside is untrusted. And you'll notice a few things about this, mainly how much larger the untrusted area is than the trusted. And importantly, that it's unbounded. The trusted is very bounded and specific. You can enumerate all the trusted states, whereas the untrusted is unbounded. And you know, in a practical way, it's impossible it's to enumerate the states that can happen. And this is why blacklisting doesn't work. When you try to enumerate the stuff that's not allowed, you have to do whitelisting and enumerate the stuff that is allowed, which you trust. So, well, how does something from the untrusted side become trusted? After all, we have to interact with all this stuff, otherwise our application is pretty worthless. So through every developer's favorite activity, validation. That's the most fun thing to do when you're developing an application, right? That's the first thing you start with. You're fired up to start with validation. So well, hopefully after this session, you'll at least think it sucks a little bit less than you did before. So, well, two things can happen, of course. Either the validation passes, we trust the data, or we do not trust it and we reject it. So we keep it outside our circle of trust. And if we're talking about validation, just to define it a little bit more, this is the typical kind of validation that you probably think of. Making sure that the data you get is valid in your domain, like is X even a number, the data that Bob wanted to transfer to the bank or whatever. There's some other fancy names, canonicalization, normalization, stuff that must happen before validation. Here's a typical example of normalization where you get a file path. Maybe you allow people to upload stuff to or download whatever from cpublic file upload. And if your program only validates the beginning of this unnormalized path, then you'll say, that's fine, it's cpublic file upload. But you have a path traversal attack there with a ... slashes that the OS then will collapse to secrets keys, which, well, obviously somewhere you don't want the user poking around with their uploaded or downloaded files, whatever. So normalization must happen before validation, and you see why there. There's something sanitization where you clean up dangerous unknown data, typical log injection. I'm willing to bet that almost none of you is doing sanitization of your log data because it's so common when we do reviews or everything. You take some value and it doesn't fit in your domain. You log the error. Say, yeah, I received some invalid data. This is the one because it's good for error checking or debugging later. Well, then the user can inject log entries into your log, which could make like legal proceedings harder later if you can question the log. So that's something to think about. If the user knows what kind of log format you have, you can inject evil log entries and confuse your debugging or error checking later. Excuse me. We touched upon this before. Always prefer whitelisting over blacklisting because, well, the red area is unbounded and the green area is bounded, right? You cannot enumerate all the invalid stuff. And another good thing about being strict with validation is that it finds bugs early, right? Instead of you get some error like 8 steps down in the code and you have to spend 1 day, tracking back, how did this end up down here near the database? And it turns out that it's a number being negative instead of positive up here that you could have caught really early up here in the UI almost of your application. So it's not only for security, it also saves you time and headaches. And every time you do validation, every time you have a parameter or something you don't need to validate, you have to ask yourself, what is the largest acceptable range? And then don't accept any more than that. Don't think, well, maybe in half a year, people will transfer these large amounts, or maybe, they'll change the expiry time to a few more years more on these credit cards. I'll just put that in there so we don't have to do an update. Don't do that. Just be really strict, and if you have to change it, update your software. That's better. So that's trust in general. It's the foundation of software security. And let's move on to the first pattern here, shall we? Domain-driven security. How many here have heard about domain-driven design? Hands up, please. Okay, yeah, that's good. So it's not really complicated. That's that you always model your domain like with proper objects that interact and are created in special ways. So it's not really complicated, but you can look it up if you need to know more. And the term, or this pattern, domain-driven security, it helps us with a trust boundary and it gives us validation everywhere in a good way. And the pattern was coined by 2 developers at the Swedish company Omega Point, John Wilander and Dan Berg Jonsson. So domain-driven security is basically domain-driven design plus some conventions for input data validation that we're going to take a look at now. So let's go back to our interaction with Bob and the bank. Here's Bob again. So this is a new transaction. The bank trusts him already and then forgets to validate. And Bob wants to transfer a negative 1,000 euros. Sure, go ahead. Ka-ching! Bob gets a almost soon to be outdated Swedish 1,000 euro kroner note in his pocket there. So the problem with validation is that the same validation always has to be performed over and over again. And that's probably why it's easy to forget to validate somewhere. because you can't really see the forest for the trees. And it ends up everywhere in the code if you don't manage it. So probably that's why it's so easy to forget it, because you see it everywhere, and then if it's missing at one place, it's easy to miss. And it's easy to forget that you also need to validate from internal sources, sources that you think cannot give you bad data, such as your database, for example. I mean, surely you've sanitized and validated everything that comes in. When it comes up again, can I really trust it? Well, there's something, if you haven't properly validated it, if the attacker is really clever, they can store scripts, for example. Cross-site scripting is a typical web attack where an attacker has been able to put some script text in your database, and then you show it on a page, maybe as a username, it says script, and then some JavaScript gets executed, and then you can attack other users with this script. So if we go back to the circle of trust here, we have validation of primitive types like strings and integers. You can still be secure, right, if you remember to do the validation everywhere. But it's hard to look at a variable in your application object to see if it's trusted or not, if you're dealing with primitive types, because they look just like any other type. What domain-driven security says is that primitive types and data structures are untrusted by default. If you see a string, an integer, a byte array, a collection of whatever being passed into a public function or returned by a function on your object, then that data is untrusted, and you shouldn't really see it there, because you should only see domain objects, which I'll explain what that is. Domain objects, by convention in domain-driven security, have built-in validation, meaning that they cannot be instantiated without being validated internally first. If the validation doesn't pass, an exception is thrown and the object can't even be created. So let's see here. So inside our circle of trust then, we'll never see strings and integers being passed around. We'll only have proper domain objects. Like the string would probably correspond to an account object, an account number. An integer can be an amount object, which is then properly validated. And the good thing with domain-driven security is that you automatically get data validation everywhere. It's not only where you think that, oh, here's the trust boundary, I'm at a web service, there's a trust boundary here, I remember to validate the input data. No, every time you try to instantiate a domain object, it's validated, and you'll immediately catch any evil data or out of bounds data that come in. So it's validation everywhere, not in the places where you just expect the bad data to appear, because it's hard to understand where all the bad data will appear. So here's a typical domain object then. An account number, which is constructed with a value, and by convention then, the domain object is immediately validated upon creation. So there's no way for us to end up with an invalid domain object here. And another not necessary but very useful thing with these domain objects is if they are immutable. I'm going to be talking more about immutability later. It's basically that they can't change. The internal state of the object cannot change after they've been instantiated. So you see that string, the value here is a final, and this is Java. The final means that it cannot be set again, and there's no setter for this value. Just a quick hands up. How many are programming in Java here? All right, C#? Okay, and the others? All right, yeah, okay. So it's, well, good match then, because there's going to be some Java and C# examples here. Cool. Right, every domain object is validated upon creation. There's no way for us by convention to end up with an invalid domain object. We must, of course, remember to do this validation in every domain object, but after a while it becomes second nature. When you do your objects. So if we go back to, we have an example, we have a web service that takes some untrusted SOAP data from the outside. We validate it, we get a user object, an account object, whatever. But when we get some invalid data, it will just bounce off as an exception. And we don't have to worry, we can be happy with this. So another thing with this is that these primitive types, if you forget to do this, it really pops out. So here we have a reticulate function that takes a spline and reticulates it a certain angle. So, you know, what's up with angle? That's an integer. Well, it's not a domain object. We can't trust this. Is angle allowed to be negative? What's the allowed range of angle? Maybe we can only reticulate a few angles to the left and right, whatever. What is the allowed range in our domain? Now the reticulate function has to remember to perform this validation. So of course this is what it should look like. We should have a proper angle object for our domain that is validated with the allowed ranges or whatever for these angles. And I chose this example just to highlight that something as trivial and simple as an angle deserves its own domain object and therefore validation, or the other way around. And why not? It's easy, it's cheap to create objects. You don't have to worry about a cost or overhead about this, and you get validation everywhere. So the domain-driven security essentials. The type system ensures that the correct domain object must be used. We're not passing in integers, strings, whatever. That could be whatever integer or string. It has to be that type of object. So that's using the type system. And by convention, all domain objects are valid. And of course, there are still business rules, but you don't have to worry about the building blocks, like the foundation of your application. Those are still valid. Those are always valid. And the good thing when you do like a reviewer software, you know that you forgot to validate something. If you see primitive types being passed around, you're only supposed to see domain objects. So it makes it really hard to see, really easy to see where you forgot to do validation. And just one more thing that I'd like to shoehorn into this domain-driven security discussion. We're talking about domain objects. Is the null question. Don't use null. Never let null carry information. And what do I mean by that? So null is an error. Null is just a way we have to denote that something is not pointing to anything. We need null to say that this has not been assigned. It's like a thing we have to deal with in object-oriented languages. And you should never see null in your code except for null checks in your domain objects if you're paranoid with your validation. So because if like typical bad uses of null is that you want to indicate that something doesn't exist. Oh, I couldn't find this object from the database, I'll just return null. Don't do that, because null leads to hard-to-read code and null pointer exceptions where you cannot separate an error state from a normal state in your application. So if you want to indicate that something does not exist, use something like optional of T. It's in Java 8 now. It's a really simple thing that you can write in C# as well. Because returning null is like returning a burning bag of dog poop. Okay, if the code's clients manage not to get burned by this bag, they're still left with this disgusting, smelly object that then they have to deal with, right? Just to stump it out or something. So don't be that person that returns null. The other time when you might feel inclined to return null is then you get this, oh, this shouldn't happen. I'm really supposed to find this object. Oh, I'll just return null. No, just throw. Don't be a chicken. If this is an exceptional circumstance in your application, well, use the aptly named exception and throw the exception. The world is not going to explode because you do that. So here's just what the optional class would look like in C#. It's a generic. We can create. You have to ask is it present? Yes. Then get the value. If you try to get the value for something that's not present, then you get an exception. So. And for you C# folks out there, there's something called the nullable type, like you can use for primitive types, which is really useful if you're dealing with databases. That's the use case for which was intended, because databases deal inherently with null. So they might return null, and it's a really nice way of doing this. But it's not the same as optional, because here's just another horrible way of assigning null now to a primitive type, right? You can get null 2.0 in your application. So only use this at the fringes of your application, at the database or at the UI layer. It can be useful for UI widgets, like radio button, on, off, not set kind of thing. So please don't put this in your application. Make a proper optional object instead, like that. So okay, that's it for domain-driven security. We talked about trust, domain-driven security, and I'm going to talk about another pattern now that focuses on the trust boundary itself. Because maybe it's called the untrusted pattern, where make trust a first-class concept at trust boundaries. The thing with domain-driven security, it's great, you should use it if you can, but maybe if you're trying to introduce it into a legacy project, it's major surgery. You might not even have a domain object at all, right? A domain model at all, right? So where domain-driven security is defense like in depth everywhere, the untrusted pattern is more of a perimeter defense, where you just want to lift up where the trust boundary is so it clearly is visible in the code. So let's take a look at this function. We're at a security boundary here. Foo takes some input bar. Bar comes from the untrusted side of the trust boundary. And the do something with function is then on the trusted side. And the thing you see here that you can't really see the trust boundary, right? It doesn't stick out. Yeah, we're doing validation, but so you know something is untrusted probably, but there's really no way of telling where the trust boundary is. So one useful way, if you don't want to, if you want your code to be almost like bytecode compatible, is just to rename it. It's a pretty effective trick if you're doing like the slow refactorings towards finding your security boundary. Just rename your variables accordingly. If something is untrusted, why put untrusted underscore in front of it? I know this violates the naming guidelines, but hey, it's pretty useful. So just ignore that rule in your IDE or whoever complains. So the good thing now is that when you look at a function here, you have this other function that takes some untrusted bar, untrusted frob, and just like in the spline angle example, what's up with data? How come we trust it? We trust it obviously because it doesn't say untrusted before it. So now it's really easy to see that we forgot to validate the data byte array, which is probably bad because it's full of buffer overflows or whatever. So yeah, you can take it one step further, have the validate method return the bars, and makes it a little bit neater. But we can do better than this. There's really nothing that forces us to do validation here, right? We could just take the untrusted and just assign it to a bar, just pass it in to do something with function. No one would be the wiser. So what if we do this? This is the untrusted pattern here. We can use the type system and make a generic object. I'm saying generic, it's the right thing, yeah. Yeah, generics. I'm thinking about templates in C#, but it's generics here. Yeah, sorry. So we wrap our value in a untrusted container. And we want to make it so that the only way to get the value out of this untrusted container is to do validation. So I'm going to show you how to do this in C#. Let's take a look at this is what the untrusted class will look like. And do you see anything strange for this? Anyone see does this class seem useful at all? How do I get the value out of this? Because the getter is private, right? So seems impossible. We cannot get the value out of this untrusted box that we've locked it into. Well, in C# there's something called assemblies. Assemblies is like a jar file. It's the packaging unit in C#. And there are something called assembly directives, which is like the manifest file for the jar file, basically. And there's an assembly directive called internals visible to, where you can declare that all the internals, the private variables in this assembly, should be visible to everyone in this other assembly. So what if we have an assembly called validation, and the validation assembly has a validator class that does validate of t, and then returns the value if it's valid, otherwise throws in a validation exception. And implementers of validator would then override the template method inner validate to do the actual validation. So here, the validator can actually get the value because of the internals visible to directive. So it would look something like this. We get an untrusted of string where the account number is. We have to new up an account number validator, call validate, and then plop, we get the trusted validated value out of it. There's no other way for us to get the account number out of the untrusted container. So we cannot, technically, we cannot forget. We've put a straitjacket on ourselves and we have to do validation, which is great. Of course, we can do a do nothing validator. That's bound to pop up in the project sooner or later. That will just return it without doing validation. But at least you know you're cheating, right? So to create these untrusted objects, we need some glue mapping code, right? We have to new up these untrusted and then just remember to pass them in at the untrusted boundary. It's not very elegant, a little bit clunky. It would be nice if this happened automatically. As far as I know, it can't really be done in C# unless you rely on some framework feature like ASP.NET model binding. You can take your values and then always wrap them in your model binder and pass them to as untrusted of, which might be semi-useful because the validation is really good in ASP.NET MVC anyway. Do we have any C++ programmers here in the crowd? Yes, all right. The untrusted pattern is more elegant in C++ because C++ has something called implicit constructors and friend classes. The friend classes means that you don't have to declare it at the package scope. You can say at the class scope that this should be accessible to validator instances. And implicit constructors means that you don't need this glue code. You can just declare your inputs as untrusted of, and then C++, the compiler, will understand that there's a path through the untrusted constructor to your object, which makes a lot of people hate implicit constructors because it's really complicated, but it's very useful in this case. So I'll leave it as an exercise for the reader to implement this in C++. So right, that's the untrusted pattern. Again, domain-driven security, really good should be the preferred method, I think. If you can't do it, try the untrusted pattern, either by renaming or just doing the pattern full out like this. So I mentioned before immutability, which is really a good thing. And we've talked a lot about trust and that we need to validate something before we can trust it. But what if something can change after we validated it, when it's inside our circle of trust? How can we trust it then? It's been changed. We haven't validated it anymore, right? So no matter if we go from the outside to the inside in the circle of trust, or from the inside to the outside when we pass something out, the objects that we pass over the trust boundary should be immutable. They shouldn't be able to change. Otherwise, you can, with clever race conditions, bypass your validation. So let's take a look at this. So maybe your application handles concurrency. Probably, if you're doing a web application. You have hundreds of threads. How does that affect your validation? The thing you just validated, is it still valid? That's the main question. So we talk about talk to, time of check to time of use. And you've all seen this, maybe without thinking about it. Here's a typical method, Java method that transfers some amount. And first it checks that the account contains this amount, and then it transfers it, otherwise you get a validation exception. So we have a time of check, TOC, and a time of use, TOU. But what if another thread modifies amount between time of check to time of use? Then we become millionaires here. So the problem is that we can send it, if the amount object is not immutable, then we can pass in an amount object that passes validation, but then is changed and modified before the actual use of it happens. This can, of course, leave us vulnerable to an attack then. So the solution, well, immutability. If the amount object looks like this, if we have a final here, the value cannot be changed, and there's no setter, well, we're good. Nothing can change between the time of check to the time of use. So get rid of those setters, right? And use final or read-only in C#. Immutability is great. It significantly reduces the talk-to problems. It plays very well with domain-driven security, as I mentioned, and readability, parallelization, event sourcing, etc., etc. Immutability should really be the norm. You should strive for it. You should be so used to it that when you see a mutable object, something that can change, you should just feel bad and try to contain it and move it somewhere else. Let's take another look at a race condition here. How many of you knows what a race condition is? Hands up. Okay, cool. That's everyone. So when some output is dependent on the sequence or timing of other uncontrollable events, that's a race condition. And in web software, it's typically then the web request threads, right, that compete, race for access to a resource. So apart from leading to super hard bugs, like Heisen bugs that you cannot debug, you cannot get this when you're debugging often, then it's a security problem as well. Imagine this: you're doing like a shopping cart, a wizard. There are 3 steps where the user first enters the wizard, chooses a product, and then checks out. Here we have a static map of the data we have to assign to each user. Each user has an identifier, which is a GUID or UUID in Java, unique identifier. And all you concurrency-aware folks in the audience, you see the static keyword, and you're like, oh, I would never put a static, in a web app. That's, begging for problems. But this could also be a service. If you have a dependency injection container, maybe your service is a singleton, then this would be just a regular instance variable, which it would be the same because it would be shared by everyone. So it's just static for the ease of the example here. So, okay, step one, the user enters the wizard, gets assigned a new unique identifier, gets some data, and gets the identifier returned. And step two, we get the key and the query string probably from the user, and then now the user has chosen some product. So, okay, we update your wizard data with this product ID, and then in the third step here, it's like the checkout step. We get the data out of our map, and we check that the user has access to this product ID. And if she has or he has, then we do something with it. So, does anyone see what we could do here? What an evil user could do? What if we hammer the application with sending step 2 request to it while we're doing the checkout? We understand, I mean, this is not far-fetched to think that, okay, in step 3, I understand that some validation is going on because I cannot choose this secret ID that I somehow have learned about. So maybe there's the talk to vulnerability here. I'll just keep bombarding my application with step 2 request while I do the step 3. Maybe I'm lucky and will inject right in between here, and I will actually get access to this secret product ID. So the solution, of course, is to make data immutable. So we have the example again, looks exactly the same, but we have something called immutable data now instead. The first step is the same. The second step, here's the difference. Instead of just assigning or changing the product ID on our existing object, we can't do that anymore. We have an immutable, unchangeable object. We have to create a new one. So you have some convenience method on the immutable data object that's called clone with new product ID, I guess it should be called. So it takes all the other fields, I'm sure data has a bunch of fields in it, and clones those and assigns a new product ID. And then we set that into our map. And the third step looks exactly the same. We still have the time of check to time of use. We can never escape from that, right? But now data is immutable. It doesn't matter how many step 2 requests I bombard in the middle there. I'm just going to assign a new object. And the validation and the check and the use is always going to be performed on the same data. So immutability, it doesn't solve all the problems in the universe, of course, but it's you can consider it as a security spray. It makes your code a lot easier to understand, a lot more robust. And it should, like I said, it should really be a good reason. You should have a really good reason not to make your data immutable. Okay? It should be the norm. Mutable objects, something that can change, should be contained, isolated, and only poked with a stick. So, because a lot of time you mix it, right? You have an object with a lot of properties, and many of them will never change. Well, then factor out an immutable object out of that, put the mutable state in another object that you only touch at certain times. Makes everything a lot easier and a lot more secure. Should be the norm. That's it about immutability. Let's talk about the final pattern here, something called the inverse life coach pattern. And to understand the inverse life coach pattern, we first have to look at the life coach anti-pattern. So the life coach anti-pattern goes something like this. This is the life coach speaking. You have done nothing yet, my friend, but you are already a success, right? No matter what happens in bunch of code, you will succeed, right? And even if you don't, I'll still charge you. It's awesome being a life coach. So if for some reason you erroneously exit somewhere in bunch of code and have not set success to false, you will return success true, which is wrong, right? Because there was not a success. And this is a large part of the GOTO fail bug that you might heard about that happened to OS X that made TLS validation in OS X disappear. That they added the life coach ANA pattern together with some duplicate GOTO statements. So what you should do then, of course, the inverse life coach, well, you assume failure. You are not a success. You have to prove yourself in a bunch of code, and maybe if you're really good enough, you really got what it takes, sure, go ahead and return yourself. That's a success. But we can do better. This is like a C example. We are using a object-oriented language probably. So typical pattern looks like this. We fail fast. Like we try, check and assume failure and throw an exception if something is wrong. There can be a bunch of these statements. If not has access. If not, account is allowed to operate on this method. If not. It should be really hard to go through this, to actually go up into a bunch of code. And then if we, against all odds, make our way through a bunch of code, then sure, return. But we don't return a success. Did it work, true or false? No, you should only return a proper domain object. The only ways of exiting this function is either to explode in an exception or to, through a really narrow path, challenging path of success, end up with a valid domain object. You should picture the function as the Atlantic Ocean, and you are a sunburned, chain-smoking Frenchman that has to windsurf across it. That narrow. That's the path of success. Okay. So there's no way of you to exit this without having a valid object. We're about ready to wrap stuff up. I realize I'm talking really fast, but hey, that's how it goes sometimes. I want to. There are 5 things that I want you to take home with you from this session. The first one is consider your trust boundaries. Where are you placing your trust? Think about the circle of trust. Everything outside is trusted. You have this small subset inside that's trusted. And validation is the only way of knowing this, where if your data is valid or not, or trusted. So really think about this. Where are you putting your trust? And minimize trust, of course. You should really try domain-driven security. It's easy, it's simple, and it might seem almost trivial. Of course, yeah, just put some validation in your domain objects, but couple that with immutability. And if you've been using it for a while, it's so great because your objects are always valid, and you catch your bugs really early, and you don't have to. You actually get a bit hooked on validation. You want more validation. So, if you see a primitive type being passed around, you're like, oh, what's this? It's not trusted. It's so easy. Just change it to a domain object. It gives a great defense in depth. And like I said a few times, immutability should be the norm. Right? Try to isolate your mutable state. If you see something mutable, you should feel bad. Something with setters, right? It's horrible. Try to contain it and minimize its spread, because maybe you realize that you didn't even need that flexibility to have mutable state. You can kill it off. Yeah, not much to say about this one. Null is an error. It's an invalid pointer. Do not assign any other meaning to null. Okay, life becomes so much easier when you don't pass around null. You don't have to do null checks. You don't have to see that ugly word null everywhere. It's just gone. You can forget about it. You'll sleep better at night. Everything's better. Use optional of t to indicate missing values. If a missing value is an exceptional thing, why throw an exception and watch the world burn? It's going to be great. Fire your life coach. Be a pessimist. Assume failure. Narrow path of success. You're windsurfing across the Atlantic. You're a sunburned Frenchman. Blah blah blah, like that. That's it, folks. I hope you enjoyed it and that you learned something new, and you can apply these patterns and concepts immediately when you get back to your programming activities. Don't be shy. Feel free to contact me. I have like 7 tweets there, but if you tweet, I get an email, so then I know you tweeted me. I just want to plug this a little quickly here. There's a Security Day conference in November. In Malmö, just across the water. Some really interesting stuff there. It's in Örebro. Check it out. And please remember to rate this session. And we have about 13 minutes for questions, so don't be shy. Thank you. All right.
Do we have any questions?
Yeah.
Right, thank you. You said you also do code reviews in your work.
Yeah.
How often do you see those practices you just preached?
Not that often. No, it's that's why they're so useful. I mean, I like to talk about, it's easy to be like discouraged when you think about security. I guess you're thinking, oh, well, you know, it doesn't matter if I do this or not, because, you know, if someone wants, they can still hack my application. But it's not true. It's not really true. Sure, if they're like a nation state is after you, the NSA or whatever, someone who's really skilled and determined, yes, they probably can hack your application in your company or whatever. But, you know, it's the 80-20 rule. With a small amount of input, like 20%, you get 80% of the success. So this, just doing proper validation, finding your trust boundary, immutability, really simple things, that's going to make it a lot harder for the average, you know, hacker from, I'm not going to say a country, just somewhere to hack your application. So, yeah, so you can really do a lot with small things, I think. Yes, in the back.
What need do you see for testing and validation once you're within the test trust boundary?
I'm sorry for.
So once you're within the trust boundary, what needs do you see for continuously testing and validating data?
Well, there is, if you're inside the trust boundary, you have validated your data and it's trusted, right? There's still business rules that need to be validated, but you do not have to validate your data again. You can because it doesn't hurt, but you don't have to, right? Because you should trust your system, right? You have a method, you should trust it. Otherwise, you'll just end up with validation a little bit scattered everywhere on the code, around the code. But if you do this properly, then you should be fine. But if you have something super sensitive, maybe you should add more layers. Like if you have this critical part of your application, it doesn't hurt to do the validation again, right? Because maybe someone changes this object out there, and then you end up with bad data here. So. But when I do this, I use domain-driven security as much as I can, and then for the more security critical things, I add a few more layers right there, like when you're doing your credit card processing or whatever, right there. Just do a few more things, just to be sure. Belts and suspenders. I think there was someone here before. Yeah.
Do you ever break these rules in performance critical sections of your code?
Never, ever, never. No, I haven't.
And there are some situations where even opening a try catch is performance critical.
Okay. yeah, but I want to stick my neck out and question that a little bit. If it really is performance critical. I mean, I don't know what you work with, but it could work at Facebook. Okay. No, but I just want to caution against like premature optimization. You really need to measure that. And if you know unwinding an exception is too expensive for you, sure. But there used to be like talking about Java that exceptions are expensive, you can't use them, you should use return values. That's like 15 years ago. You know, it doesn't apply anymore. But just make sure by measuring that that's really the case, and then sure, go ahead and do something else. But try to use these exceptions as much as possible. Yes?
You talk a lot about immutability, like a very good thing, and I agree, but our languages like C# and Java are made for immutability. It's pretty hard to do so. Let's say you have some object and you have like 10 fields, and you want to change one field. Then you have to make a constructor, you have to copy the 9 fields and the one you want to change. Do you understand what I mean? So it's not easy at all. I mean, our language isn't code for immutability. So it's quite easy to say, just do it, but in fact it's totally difficult.
I don't think it's that hard, actually. No. But it depends. Maybe if you have 10 fields, maybe it's too much. Maybe you can refactor into 2 objects. Of course, it can be annoying, you know, but you can use the builder pattern instead of making a huge constructor you have to call. You make a builder object that you set. It's a pattern, you can look it up. I don't think it's that hard. I don't think. Sure, they're built for mutability. It's not like a core concept. It's not a first-class citizen in the language. But I think it can be used successfully without any pain. The benefits outweigh the pain. There is pain, yes, but it's a good pain, right? So, sorry. Yeah. Yeah.
Second question, you said like the objects should validate themselves, but often you have external dependencies, so it's quite easy to say, okay, an angle should be 0 to 90 degrees or whatever, but if you have to check before you make an account, does it exist already? Then you have an external dependency on the database, and you can't put that inside the entity because that would suck. I mean, so it's not so easy as you put it, because I mean, the entity, okay, I'm a valid integer, but maybe some other entity already have my account.
Yes, of course. It's like the domain-driven security ensures that your basic building blocks are valid. So yes, of course, you have to validate that you have access to this account and do these just regular checks before you even create your object. Yes, you should never call a service from your domain object. Of course not. So you're right, absolutely. It doesn't cover everything, but it sure beats the heck out of having no validation or having validation everywhere. So yeah, it's not a silver bullet, but it's really good, I think.
Well, if you have no more questions, I think we'll just say thank you.
Okay, thank you.
Finish early.
Thank you.